Right, in this video we're going to be looking at finding equations of tangents to graphs or curves at given points. So we've got y equals 3x squared plus 9, and we're going to try and find the tangent where x equals 2. We have a quick look at the graph. Here we go. This is the graph of y equals 3x squared plus 9. Okay, and here's the tangent where x equals 2. And we want to find the equation of this purple line given this blue curve. How do we do that? Well, we don't need to draw it to do it. Okay, what we're going to do is we're going to use some algebra, we're going to use some differentiation. So the first thing you need to do is differentiate y equals 3x squared plus 9. So we find dy over dx, and that is equal to times by the power. So 2 times 3 gives me 6. Take 1 off the power gives me x to the 1, which is just x. Remember, numbers do not affect the gradient function. So therefore, when you differentiate this, you're finding the gradient function, so that 9 just disappears. So we're just left with the gradient function is 6x. And we want to find the gradient when x equals 2. So at x equals 2, dy by dx is equal to 6, 2, which equals 12. So therefore, the gradient of the tangent is equal to 12. Now, there's two ways we can go about finding the equation. The first thing we need to do is we need to find a point the line goes through. So we know the x value. We got x equals 2. We need to find the y value. So y equals 3 times 2 all squared plus 9. So 2 squared is 4 times 3 is 12 plus 9 gives me 21. And the easiest way then to calculate the equation of the tangent is to use y minus, I'm going to call this a equals mx minus b. Actually, I'm not going to write it that way around. Sorry, I apologise. I'm going to do y minus b x minus a. So the point AB is a point on the line. We take the x1 away from the x value and the b1 away from the y value. So the y1 away from the y value. And then we times by the gradient here. So using what we've got, the gradient is 12. So m is 12. We know a point on the line is 2, 21. We know it goes through the point 2, 21. So y minus 21 equals 12 times x minus 2. And that is the equation of a line. If you were just doing that for an exam, that would be a perfectly good answer. But this one's in the form y equals something. So we've got y minus 21 is equal to, multiply this out, 12x minus 24. Draw that down a touch to give us some space. So we get y is equal to 12x, add on the 21 gives me minus 3. So y equals 12x minus 3. When we go back to our graph, we can see this is going one along, okay, and it's going one along, and it looks like it's going about 12 up. It's quite hard with a scale. We can definitely see that's crossing at 3, so that's good. But it's much harder to see how much we're going along for every one up. It looks around about 12, so it seems like we've got our right answer. Okay, let's do another one. So we're doing y equals 5x squared minus 3x at x equals 3. So let's differentiate this. So we differentiate this, we get dy by dx is equal to 2 times 5 is 10. Take 1 off 2 just leaves me x. 3x differentiates to give me minus 3. You can just imagine just the minus 3x. Y equals minus 3x has a gradient of minus 3. So therefore, the gradient of this is 10x minus 3. So at x equals 3, we get dy by dx is, dy by dx, drop that out and write it properly, I was ahead of myself there. Dy by dx is equal to 10 times 3 minus 3. So that gives me 30 minus 3, which is 27. So the gradient of the tangent is equal to 27. Quite a big gradient, very steep graph at that point. And we can now find, we need to find the y value when x is 3. So at x equals 3, because we need to know a point on the line. At x equals 3, y will equal 5 times 3 squared minus 3 times 3, because we've got x equals 3. So you see I'm just substituting x into every part of that to find the y value. So y is equal to 5. 3 squared is 9. Minus 3 times 3 is 9. Equals 45 minus 9 equals 36. So y, take away y1 or a, whatever you want to use. If you use, sorry, not take away, if you use the point a, b, which is the point 3, 36, we take the y value away from y, times by the gradient, which was 27, x minus the value 3 here. Okay, so if I just highlight all the right points, you see the 3 comes from there, the 36 comes from there, and the gradient comes from here. We found the gradient of our tangent. And then we can multiply this all out to simplify and get the answer they want in the y equals form. We get 27x minus 3 times 27, so 60 plus 21 is 81. Add 36, so y equals 27x. Add on 30 to that, I get 111 plus 6, 170. Oh no, I've got to add that on, so that's going to get me down to 51. Take off 6, that's going to be 45, minus 45. Okay, because you're adding that onto a negative number. So we get 27x minus 45. Right, I'm going to speed up now. I'm just going to run through it much more quickly. Went nice and slowly for the first ones and just go through the ideas. So here we've got to multiply out our brackets before we can differentiate it. So we get x squared. Remember that's x minus 2 times x minus 2. So x squared minus 2x plus 4. Go back to a video on multiplying out brackets if you can't quite follow why that's true. And we get that. And then we differentiate. Remember, times by the power, take 1 off the power. So times by 2, take 1 off, gives me x to the 1. 4x will just go to minus 4. Any number that's added onto it doesn't affect the gradient, so we don't bother with that for there. At x equals 1, we have dy by dx will equal 2 times 1 minus 4, which equals minus 2. So the gradient is equal to minus 2. And we want to find the y value of the tangent. So if x equals 1, then y will equal 1 minus 2 all squared. Look, x there, put x equals 1. 1 minus 2 all squared gives me the y value. That's minus 1 squared, which is just 1. So we know we're at the point 1, 1, and the gradient equals 2. So we get y minus 1 equals the gradient times x minus 1. So we get y minus 1 equals 2x minus 2. So y equals 2x. Add on 1 gives me minus 1. Okay, trickier one. Rewrite this as a negative power, much easier to differentiate. So you get 6x to the minus 1. If you're not good on powers, go back to my videos level 6 to 7 and levels 8 to 9 on powers. Okay, recorded last week. So we differentiate this. Times by the power, we get minus 6x to the minus 2. We're taking 1 off that power to get minus 2. So at x equals minus 1, we get dy by dx equals minus 6 times minus 1 to the minus 2. Let's do this first. Now, what we've got here is in fact minus 6 over minus 1 squared. Okay, that minus means put it on the bottom of the fraction, put 1 over it. The minus 1 squared is 1. Minus 6 divided by 1. So we get that equal to... get that equal to just minus 6. So the gradient will equal minus 6. At x equals minus 1, we can find the y value is 6 divided by minus 1. So therefore the y value is also equal to minus 6. So for the tangent, we know that we've got y minus, the coordinates were minus 1, minus 6. Take away the y coordinate that it goes through, equals the gradient, which is minus 6, times x, minus the x coordinate goes through, which is minus 1. We get y plus 6 equals minus 6. Multiply this out, x. Minus minus can be plus, times minus 6 gives me minus 6. And so therefore, take away that 6, we get minus 6x minus 12. That's our answer. Okay, we've got a longer question now. We're going to build up a whole question that you might get in the exam. So we want to factorise this first. So, how are we going to factorise this? Well, we're going to put an x at the front of each to get the x squared. And then we're going to think, is it minus 1 and 2, or is it 1 and minus 2? Is there anything else it could be? 2 times together gives minus 1, so no, there isn't. So we change these numbers around. We want a minus x, so we need the minus 2 to be bigger. Okay, but the minus 2 to be bigger. We put x plus 1, x minus 2. We can multiply it out. Let's just do FOIL to check. Check our answers. We always have lots of time in the GCSE, so check your answers. First two things tied together. X squared, outer two things minus 2x, inner two things plus x, last two things minus 2. Add these two together, you get the minus x, you get the minus 2. So we've got that right. Where does this curve cross the positive x-axis? Well, let's just quickly draw that using Desmos. I'm just going to get a new graph. Let's just hide that one. And I'll just put in x squared minus 2. Let's just put a little y at the front just for completeness. Y equals. So there's the graph I've just drawn. Ignore this tangent. Let's get rid of that. Okay. So there's our graph, and we can see, look, it's crossing at 2 and minus 2, right? That's where the x-axis is. It crosses the x-axis there. Okay, we're crossing the x-axis all along here. And this is where the y-axis is equal to 0. Look, the y-axis is 0. The y value is 0 along here. So if the y value is 0, we want to solve this equal to 0. So 0 equals x squared minus x minus 2. Find out where it crosses the axis. And so therefore, we know that this is true. Now if you know that is true, then either x plus 1 equals 0 or x minus 2 equals 0, and this implies x equals minus 1 or x equals 2. Where does it cross the positive x-axis? Well, it's not the minus 1, it's going to be the 2 is our positive value, so that gives us our x value. And the y value is obviously going to be 0 because that's what the y value is all the way along the x-axis. Now we want to find dy by dx. So let's do that. Times by the power, so it gives you 2 times x. Take 1 off the power gives me 1. X to the 1 is actually just x. Minus x minus 2. Well, if you just consider the minus x minus 2, the gradient of that is just minus 1. So we get 2x minus 1. Now we want to find the gradient of the tangent where the curve crosses the x-axis, the positive x-axis. So this was here. So we want to find the derivative, the gradient where it crosses the x-axis. So we want to use the value of x is equal to 2. So if x equals 2, this implies dy by dx equals 2 times 2 minus 1, which is 3. The gradient equals 3. And we want to find the equation of the tangent at this point. So we're going to use y minus a equals mx minus b. We know m is 3. And we know that it crossed, go back up, at 2, 0. So it crosses at 2, 0. So A is 2 and B is 0. I've got those the wrong way around. I apologise. The equation we use is minus B minus A. So the y minus the b value, the naught, y minus naught equals m x minus the a value 2. So y equals 3x minus 6. If you use y equals mx plus c, you can find out the plus c by putting the y values and x values in. So if the y value is 0, we know that m is equal to 3, we know x is equal to 2, and we can find c just by subtracting from both sides 6, and we get c that way. So you can choose either way. I just like this because it just gets a lot faster. Straight away here you have an equation and you don't have to do any working. So there's the equation of your tangent at this point. So remember, to find the equation of a tangent at a point, first of all differentiate here, then put the x value in to find the gradient here. Once you've found the gradient, put the x value into the original y equation, so the original y equation, which is all the way back up here. Okay, and then you can find the equation of the line by putting those points either into y equals mx plus c or into this formula for the equation of a line.